The first physical quantity that we study in thermometry comes under the heading of heat. In thermometry, we study about the measurement of temperature. Temperature is a thermal property of a body. This property is an easily measurable physical quantity. Fluids always flow from a region of high pressure to that at low pressure. Electric charge positive flows from a body at higher potential to that at lower potential. When electrical contact is made between them, electrical current flows from higher potential to lower potential along a metallic wire. In a similar way, heat flows from a body at higher temperature to that at lower temperature when they are brought in thermal contact. Temperature describes the degree of hotness or coldness of a body. If we feel and hot on touching a body, it is said to have degree of hotness. Whereas if we feel cold, we say that the body has a degree of coldness. The body having degree of hotness is said to be at a temperature higher than our body temperature. Similarly, the body having degree of coldness is said to be at temperature lower than our body temperature. The touch method gives only a rough estimate of hotness or coldness. The exact degree of hotness or coldness is measured by a thermal device called thermometer. There are many physical quantities that change with the change of temperature. The change of a physical quantity with the change of temperature can be used to measure temperature. For this purpose, the thermometer is accordingly calibrated. This property of a physical quantity is called thermometric property. It is an experimental fact that liquids expand on increasing their temperature and contract on decreasing the temperature. Thus, the change of volume of a liquid with the temperature can be used to measure temperature. Gases can gases expand on increasing their temperature and contract on decreasing the temperature. Hence, the change in volume of a given amount of a gas at a constant pressure can be used to measure temperature. Similarly, the pressure of a gas changes with change of temperature. Hence, the change of pressure of a given mass of a gas at constant volume can be used to measure temperature. Electrical resistance of metals change with temperature. Hence, a change of resistance with temperature can be used to measure temperature. Every thermometer has two fixed points on it, the lower fixed point and the upper fixed point. These points are given arbitrarily assigned numerical values which represent some fixed temperature of water. The interval between these points is divided arbitrarily into division of equal width. Depending on the numerical values of these fixed points, we have a thermometer of a particular type. We discuss liquid and gas thermometer in some detail. Commonly, there are two main types of liquid and glass thermometers. They are mercury in glass thermometer, alcohol in glass thermometer. Here we give a list of main features of mercury and alcohol. Mercury, it is a good conductor of heat. It expands uniformly on increasing, is used in a liquid its temperature, and contract on decreasing its temperature. Hence, mercury is used in a liquid in glass thermometer. Mercury freezes at 39 degrees centigrade and boils at 360 degrees centigrade. Hence, it can be used to measure the relatively long range of temperature. Uh, I has a shining silver silvery color, hence no coloring is needed to read the temperature in the thermometer. Mercury does not wet the glass surface of the thermometer tube, hence the reading can easily taken. Since the meniscus is convex, the reading is taken at the top of the meniscus. meniscus. Thermal conductivity. Since mercury has high thermal conductivity, it responds quickly to the change of temperature. Although mercury is a good conductor of heat, its thermal expansion only one-fourth of that of alcohol. Hence, alcohol expands 4 times more than mercury of the same rise in temperature. It has temperature dependent property. It expands on increasing the temperature by heating the contracts, on decreasing the temperature by cooling. Hence, alcohol is used as a thermometric substance. It has following main features. Alcohol freezes at minus 115 degrees centigrade and boils at 78 degrees centigrade. Hence, alcohol thermometers are not suitable for laboratory uses as the temperature encountered are usually alone the boiling point of alcohol. It can be used in polar regions where the temperatures are usually in the neighborhood of minus 40 degree. It is a colorless liquid. It is used colored red when used in a thermometer. Alcohol wets the internal glass surface. When it contracts, it leaves some same alcohol sticking to the capillary tube. Due to this property, reading cannot be taken clearly. It has low thermal conductivity, hence it takes a long time as compared to mercury to attain the temperature of the surroundings. Its expansion is nearly 4 times the expansion of mercury for the same rise of temperature. Hence, the scale division can be made larger in size, making it easier to read. We limit ourselves to study the mercury in glass thermometers. We take a glass tube of a uniform and fine bore called the capillary of the thermometer. The capillary tubing ends on a glass bulb. The bulb and the capillary tube are filled with mercury. After heating to drive out all the air, capillary tube is scaled. As the liquid mercury cools and contracts, the space above it in the capillary tube becomes practically a vacuum. The mainly three scales of temperature in which mercury is used as a thermometric substances, they are listed and described below. This scale, the temperatures are measured with respect to one standard temperature called the triple point of water, which is arbitrarily taken to be. Here K is pronounced as Kelvin as an approximation. This temperature is taken as 273 K. At this temperature, all the three states of water, that is ice, water and water vapor, can coexist in equilibrium. This temperature is the 0 of Celsius scale called 0 degree. Here degree stands for degree centigrade. This is the lower fixed point of the thermometer. The upper fixed point on this scale is the temperature of steam at 1 atmospheric pressure, which is taken to be 100 degree. The interval between these points is divided into 100 equal parts. Each part measures 1 degree.